Okay, good morning, people at home. Hi, we're in period 1. We're going to start a new unit.
Hi.
Let them get their silly.
I'm a one.
Alright, I'm trying to get it focused, folks. I'm trying to get this focused. So we have no packet. People at home, there is no packet because there is no toner anywhere. So we are going old school. Please get a piece of loose leaf. If you need to pause the video, pause the video. Kids in class, we are going to be simplifying radicals.
Do you want us to write that?
So, oh yeah, because you don't know how to take notes. So on your paper, write this down. This is what would be on the top of your worksheet that I would normally give you for notes, right? So before we talk about our new topic, I want to go over square roots because it has everything to do with that. So let's just talk about what is the square root of 16? 4, because 4 times 4 equals 16, right? Let me zoom in a little bit. So if you're in the back and you can't see, there's an empty desk up here. You can always grab a chair over there. You could grab a chair over here. You could try to hustle on. You don't do what you have to do, okay? If you can't see it, I'm okay with you just moving yourself without asking. Okay, so that much better. What is the square root of 25? 5. So once I take the square root, this symbol goes away, right? So I performed the operation, I get 5, not square root of 5. When I took the square root, I got just 5. Do you understand? So I don't keep the symbol over there. It's kind of the same as when you take the absolute value of -2. When you take the absolute value, what happens to the brackets? They go away. So that seems to be something that gets you tripped up in this unit. So these are really nice, but if you do like, what's the square root of 17? Is that going to be a nice integer? No, it's going to be a decimal, right? And then, in fact, it's going to be an irrational number. An irrational number, being a number that can't be written as a ratio of 2 integers. In your language, when you do the square root of 17, you're going to get a decimal that is non-terminating and non-repeating, irrational. So this is like quirky, right? So we're just going to say this is irrational. See how these came out? The square root of 16 is 4. So 4 times 4 is 16. These are called perfect squares. 16, 25. What's another perfect square? What's another square root we could take that would come out nice, Emmanuel? 49, because the square root of 49 is 7. Bryson? 9, because 3 times 3 is 9. Do you have any more? Go, Molly. 36, because 6 times 6 is 36. Give me another perfect square. Lucas? 81. All right, so the key, listen, the key to the whole unit is having a list of your perfect squares. I'm telling you, I've taught this like forever. And if you keep those perfect squares in mind, you cannot go wrong in this unit. Every mistake that is ever made with radicals, which we're about to do, is because the person doesn't pick a perfect square. All right, so it's going to be really important that on your yellow sheet, don't do it right now, but write it on this page right now, that you have a list of your perfect squares. All right, so perfect square list. Now, the only recollection, I was trying to look up like when you would need this in your life, and the only recollection I have of using radicals is in calc-based physics, because your measurements have to be exact. They don't want you, in that particular course, whatever I was doing, I have a vague recollection of it, they did not want me rounding. So they wanted me to leave it as square root of 17 because I can't write every digit in the decimal. So I'm just, like, what we're about to do today allows us to be exact. We're not rounding, we're not approximating, anything like that. Square root list is 1 times 1. What's 2 times 2? 4. What's 3 times 3? Okay, then what will come? 4 times 4? These are all perfect squares. What's the square root of 16? 4. What's the square root of 9? 3. So this is our list of perfect squares. If I took the square root of these numbers that I am listing, you will get an integer, not an irrational number. That's why they're perfect squares. Next one, 5 times 5, 25. 6 times 6, 7 times 7. 8 times 8. No, I missed one. Oh, I'm doing it in pen too. 64, then 81, then 100, then 11 times 11. And 12 times 12. How long could I go on for? Ever. We'll stop here though. Okay. I'm stopping at 12 times 12. I'm talking about the square root of 144.
We would do math battles on the bus, and everyone would get that question in like 2 seconds.
Yeah. Which one?
And like 12 times 12. Yeah, the easiest one ever. No,
it is not.
Okay. He did it all the time, so everyone just remembered it. I know.
And not just grade, every morning we would have to complete a math sheet of like 9 times 1, 9 times 2, 9 times 3, and it's like going up by each number.
I used to have his bus driver in the morning. He would have us play a math game, and he would like 12 times 12 was one of his math games.
Because most kids don't learn their facts past the tens, and then it becomes kind of an issue when you get here, you know? So,
Whenever like someone beat a 5th grader, the whole bus would go crazy.
that's so funny. Okay, regroup. So, from this point forward, and this might be kind of nice for you, Howard. What's the question? Sure, sign out. So, we have been calling this the square root of 16, the square root of 25, square root of 17. We're now going to call it radical 16, radical 25, radical 17. It just means square root. Take the square root, but that symbol is called a radical, okay? So radicals are just square roots. You can kind of use them like synonyms if you want. Sort of. Okay. So this is our little pre-prep lesson, okay? That's just me getting you kind of familiar with some of the stuff we're going to be talking about. Let's do example 1. I'm not going to label examples numbers because I know I'm going to lose track of what example number I'm on. Radical 32. When you take the square root of 32 versus, we're going to do this 2 different ways. When you take the square root of 32, is 32 a perfect square? No, so you're going to get this crazy decimal, a decimal that is non-terminating and non-repeating. What do you call a decimal that is non-terminating, non-repeating? What do you call that kind of number? Irrational. So if you were going to go and give this as a measurement, in order to give this as a decimal, you would have to round the number because there's no way you could write every digit in the number because it never ends. So there's no way you can write this as a decimal without rounding. You following? So a lot of people like to leave it like this because it's exact. Okay, this is the exact value. Oh my God, thank you. You can put them over there or wherever. Thank you, Mr. Caldwell. You saved me.
Thanks.
All right, so there's the reason for working with radicals. But we want to simplify them. This whole process of simplifying. You just got through with a whole unit on simplifying with exponent monomials, right? Like a monomial operation. So we're doing the same thing with something different. This is what we're going to do. And I'm going to give you an example, and then I'm going to write the steps for you after. I just think sometimes the steps will make more sense after I've given you a little show. So pay attention. Okay. We are going to figure out what perfect square, the largest perfect square would be nice, that goes into 32. We're going to break this into 2 factors. One of the factors, and I'll write this down in a second, one of the factors has to be a perfect square. So what I do is I go to my list and I start over here, right? So I'm looking at the number 32. Don't worry about the radical sign right now. What are some factors of 32? 8, 1, 16, and 2, 4, and 8. All right, all great. I'm going to go through the list. Which one's on the list? Can I choose 36? No, we can't even start there. It's way too big, right? So let's go 25 obviously isn't a factor. Is 16 a factor? Yeah. Yes, but so is 4, right? Yeah. I think it's easier if you pick the one that's bigger, the perfect square that's bigger, because you're going to do this in less steps. It's not necessary, but it's easier, okay? So I'm going to choose 16. So I'm going to break this into 2 factors. You're going to keep the radical. You're going to break it in so that the 2 factors each have their own radical sign. So radical 16 And you're going to say times radical. 16 times what gives me 32? 2. Okay. So you first have to make sure, before you go on to step 2, this is the part where I'm talking about moving carefully and slowly through the process. And I always checked my work as I worked. You know how your teacher's always like, check your work when you know your test. And you're like, all right. If you check it as you go, it's, I think, more efficient. So look at, first thing you should check, before you move on, check yourself. Is 16 times 2 32? Yes. First check. Do they multiply to the right product? And then the second one is huge. Are one of the two factors on the perfect square list, of one of these two a perfect square? Yes. Now you can move on. If you don't stop and do a little mental check on that, you could get yourself into a tizzy. Did you get into a tizzy yesterday on some of those problems? Be like, you got yourself all mixed up? All right. So if you kind of check yourself along the way, you're not going to get yourself all screwed up. All right. The next thing is we're going to simplify this the best we can. Well, what's the square root of 16? 4 times. And then what's the square root of 2? Is it a perfect square? No. So we want to leave that. We don't want to write any decimals down. So we're just going to leave that. There's no way to write that any simpler. And at this point, we're going to provide our simplest version of radical 32 as 4 radical 2. And you'll start to see later that that radical 2 works like a common denominator. So when we multiply and divide, add, and subtract, this kind of will be important as it is a parallel to fractions and denominators. So you can't add unless they have common radicands. You don't need to worry about that right now. I'm just giving you the reason for your task for the next few days. Okay. So let's pretend, let's do radical 32 again, but let's say that you were like, all right, 4 and 8 multiply to be 32, don't they? Okay, which one's the perfect square, 4 or 8? I always write the perfect square first. So if I was a student, my teacher said that and they didn't write it down, I'd write that down myself. So this was me as a kid. Like the teacher would talk. They would say something that was helpful, but they wouldn't record it. I would write down what they said in my notes. I found it to be very, very helpful. So it says write the perfect square first. Write the perfect square first. So I don't want to write the 8 first. I'm going to write the 4 first. Why? Because 4 is on the list. Then you want to write whatever you put here should be on the list. Do you have to? No. Does it make it easier? Yeah. Yes. Anything you do to make your life easier, you should do that. All right. What are we going to check? So we're doing that checkpoint here. Check to make sure 4 times 8 is 32. Check. Check to make sure one of the numbers is on the list. Check. Now we're going to simplify. What's the square root of 4? 2. Square root of 8 is a... You can take... You know what? Why don't you get out right now? Why don't we take the square root of 8? Just in case you're not sure. When you take the square root of 8, what happens?
A decimal.
You get a decimal. So you don't want decimals right now. There's no way you could write the whole decimal. So when you take the square root of 8, just so we're clear, square root is here above the x squared. So you're going to hit second. Hello. Well, you know what you should do first is you should turn on the calculator. Okay. That's a very good idea. All right. Second, x squared gives you your square root of 8. You can end the parenthesis or not. And you get this crazy decimal. That does not look simpler. This does not look more simple than this. Okay? So I know to you you're getting used to it, but... So I get 2 radical 8. How could... Listen, how could I get 2 different answers? I got radical 32 coming out to be 2 radical 8 here, and radical 32 coming out to be 4 radical 2 here. What's the discrepancy? Why the difference? It shouldn't be. Go, Jack.
You're using different perfect squares.
Yeah, so what? So, yes. Should the answers be different? How do we get them to be the same? It's not all the way simplified. So let's just do a little side thought, right? Little side thought bubble. I'm just thinking. You know how you simplify like 50 100ths, you could simplify it to 5/10. Is that simplified all the way?
No.
Right, it's 1/2. Right, so but could some kids have just saw 50 over 100 is 1/2? Could you have gone right from 50 over 100 to 1/2? Yeah, by dividing the top and the bottom by 50. But if you don't choose the greatest common factor, you're going to wind up having to simplify again and again and again until it's all the way simplified. Same thing with radicals. 8 can be factored so that one of the factors is from the list. What could we do? So this is 2 times 8. So take 8. What are the factors of 8? 8 and 1, 2 and 4, right? 4 is it's a perfect square. 4 is a perfect square. So bring the 2 down. Carry it along, carry it along. Don't forget about that 2, because that'll break you. Break the 8 into 4 times 2, right? But keep their radicals. Did I lose you there? So I'm taking 2 radical 8. I'm going to simplify radical 8 even further. Breaking radical 8 into radical 4 times radical 2. Questions? You good? All right. The 2 is as simple as it gets, but square root of 4, is that as simple as we could write that number? No, what's the square root of 4? 2. What about the square root of 2? Can we write that any simpler than that? No, you cannot write that any simpler. So we have 2 times 2 times radical 2. Well, that's a good time. What's 2 times 2? 4 times radical 2. Now they come out to be the same. So it doesn't really matter that you don't pick the largest perfect square factor, but it makes less work, so that would be my aim, right? That would be the goal. But you have to be very careful, because on the assessment for this, if you don't simplify all the way, are you going to get full credit? No. It's just like leaving a 0 exponent. Okay. Let's do another example. Radical. Can you see that? No. Okay. Right. How about that?
Yeah.
All right. 147. Now, what I'm noticing is I flipped my page and now I can't see what? The list. I know that you know the list in your head, but I'm telling you, if you just have it next to you, like the first thing I would do if I were you on the assessment for this, as soon as I get the quiz, I'd write down the list, because it just eliminates silly mistakes. What's the list? 1, 4, 9, 16, 25. Oh my God, you guys are so smart. Okay. So much easier with you guys. That's a 1. See right there? You should see. I grade your test. I was late. How's that? 1, and then I have to fix this one. Okay. Sorry. Okay. So 147. So here's what I'm gonna do. I'm gonna start with the biggest one. The girl in the video, the tutorial, starts at the bottom. You know what? You do you, but I think my way's better. Just saying. I like finding the bigger one so I don't have to do more work. Okay. Whatever works for you. Whatever floats your boat. So let's find the biggest common factor perfect square. 81. Does 81 work? Let's see. 147 divided by 81. I get a decimal, so that's not a factor. What about 147 divided by 64? That doesn't work. What about 147 divided by 49?
Yes.
That works. Okay. So 49's on the list, so that's the number I'm going to put first. 49 times what? 3, right? That's hard to do. We'll flip them backwards. Okay, so I broke it into its factors, radical 49 and radical 3. I'm going to check now. What am I checking? I'm checking to make sure 49 times 3 is for 147. Check, check, right? Then the most important thing that kids will sometimes mess up is that you want to make sure at least one, sometimes both of them will be. But at least one of these has to be a perfect square. And 49 is a perfect square. Now we're going to simplify. What's the square root of 49?
7.
7. Times, what's the square root of 3? A decimal, which is not a simpler version of this, right? So you're going to leave it 7 radical 3. This has been known to be one of the most difficult topics for kids at your level. Listen, I think if you do this right, I think you can overcome that stigma. I think you can really do this, right? I just think you have to, I believe that if you think slowly and carefully enough, that you can absolutely do this, okay? Does it get a little trickier? Of course it does. It's always easy on the first day, right? Remember the first day exponents, you're like, totally got it. And then like the second day, you're like, oh no. And then the third day, you're like, oh gosh. 125. Let's work our way down this list. 125. I think it's 25. Okay. That one's not so bad. 25 times what gives you 125? 5. So I'm going to just 25 times 5, 125. Check. 25 is on the list. Move on. Square root of 25 is 5. And the square root of 5 is a crazy decimal, so I'm going to leave it 5 radical 5. Okay. Let's get to something that might be a little bit next level, okay? Not really. That's not crazy. It's just different. Why don't you try radical 225? So you're going to break 225 into its factors, keeping the factors under the radical sign until you simplify. One of the numbers has to be from the list. One of the factors needs to be a perfect square. People at home.
Positive.
Actually, I'm just letting it run.
Stupid video.
Tyler, every parent in the world just heard you say stupid.
Tyler.
Not appropriate for my school video.
I know. So rude.
Wait, what the?
Wait, hold up. Wait, go to
Please. Manners. Thank you. Most important thing I always want for my kids, make sure they have good manners when they leave my house. Okay, I'm sure your parents say the same thing, yes? Good manners. Very important.
Wait, what if? What if there's like 9? The two.
I know, this one's different. Abby. Yes. 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 Yeah. All right, so what is the largest perfect square that's a factor of 225? 25. And when you do that, 25 times what? 9. Okay, stop. I said at least one. I didn't say only one. So let's make sure we understand that. Do we have at least one?
Yeah.
Yes. In fact, we have 2. 1, 2, 3, whatever. So let's simplify. Square root. When I take the square root and perform the operation, what is radical 25 in its most simplest form? 5 times. Now, square root of 9 is not a crazy decimal. It's just 3. So this is just 15, which is so funny to me because I know that that's on the list. If I had gone up past, right? If I had gone up to 15, that would have been on the list, right? Right? So that's funny to me. Anyway, if you take, what's the square root then of 225? 15. That's why we got this simplifying to 15, because 225 is a perfect square. What's the square root of 225? 15. If you don't recognize it here, that's an eyeball. If you don't recognize it at first, is it possible to still get the right answer? Yes. When weird stuff happens, you need to stick to the rules, okay? So let's give those rules. Step 1. Now, when I give the steps, they should make more sense. Factor. Can you see this? Factor. You ready for this? The radicand. That's actually the name of the symbol. Okay, here we go. Into 2 factors. I feel like when I was a kid, they're like, Julie, you're so good at math. You don't need to learn how to write. I don't think they actually taught me how to form letters. Like when my kids started writing, they'd be like, circle back, pull down, like all this way is that you're supposed to write letters. I'm like, I'm pretty sure my teacher skipped that. And they're like, here's a calculator, do some math.
Wait, we're supposed to write letters?
Well, you learned. You don't remember forming letters and there was like the worm line and the like, do you remember when your teachers taught you to write? I swear, I have zero recollection of my teachers teaching me how to make letters. I'm just saying, that's why my handwriting's so bad. I think they just gave me a calculator. Sit here. Solve this equation. Okay. What do you need to make to be a perfect square? That was freaky. Okay. Press the wrong button. I know. Well, I pressed, instead of autofocus, I pressed capture. Okay. Step 1, factor the radicand, which is the square root symbol, into 2 factors. You want to, this is not the time to make your little noises. One of the factors should be a perfect square. So that's that checkpoint. Now, the next part I'm going to write is, I'm actually not going to write it. Maybe you want to write it. The largest perfect square is best. Right? Picking the largest perfect square makes less work. Whatever you want to say, but you might want to make a little note to try, so that you remind yourself when you're doing this on your own, try to pick the largest perfect square that's a factor. Remember how it was either 16 or 4 for 32? Well, it was less work if you picked the larger perfect square factor. If you want to write it, I'm not going to write it because it's going to look like, I think, too much. All right, second step, and then I'm going to let the kids at home go. Yeah, the whole time. Okay. Step 2, take the square root of the perfect square. Or squares, right? Sometimes there's going to be 2 perfect squares if you didn't catch that the original problem. Does that confuse you right here?
Yeah. I know it like
so cross that out.
I usually just cross it out if I see it.
Or square. Or squares. That's what that means, because that's the lazy man's way of writing perfect square or perfect squares. So I just put the parentheses S, and I don't have to write both things.
Yeah, I read it. I put a slash. If I see it.
All right, or this backslash you can write. So this is the most important part right here. Okay, don't worry about all this in number. All right, folks at home, try the homework. Peace out.
Bye.
Bye.